To read in CSV and tab delimited files in SAS, we use a variation of the same program we just saw. We just need to tell SAS that now the values in the data will be separated by commas or tabs instead of a single space. In this program, you can see that the only difference is the addition of the DSD option in the infile statement. DSD stands for delimiter sensitive data. Adding this option serves three different purposes at once. First, it changes the default delimiter from a space to a comma. Second, if there are two delimiters in a row, it assumes there's a missing value between them. And finally, if character values are placed in quotes, the quotes are stripped when read into SAS. Yet another common way for data to be stored is in a text file with values separated by a tab instead of a single space. Using the DLM equals or delimiter equals option in the infile statement will allow you to designate almost any symbol as the delimiter separating values in the raw dataset. Here's a question. How would you tell SAS that the delimiter is a tab? If you can't guess, don't worry. I never would have guessed either. But as you can see, it's a pair of single quotes filled with the number 09 and followed by an X. Apparently this is the hexadecimal equivalent of a tab in the American Standard Code for Information Exchange. But don't worry about that, just save it somewhere. The raw data sets comma, comma 2, and tab are posted on the course website if you would like to experiment with them. Before moving on, recall that in the last demonstration the values for BMI-cat were truncated. That's because SAS creates each variable with a length of 8 bytes by default. The values for BMI-cat are longer than 8 characters in the raw dataset, so they're truncated in the SAS dataset. But you want to alter your data step to specify the correct length for the values in the variable BMI-cat. Fittingly, you will do this with a length statement. Now watch this demonstration and learn how to use the length statement. Take a look at this data step. It is exactly the same as the data step you previously used to read in the raw height and weight data that was delimited with a single space. This time you've added a length statement to your program. First, you specify the keyword length. Then you specify the variable name, a $sign if it is a character variable, and then the length. Notice that you can specify multiple variables in one length statement, and you can set the length to be longer or shorter than 8 bytes. In general, there is no need to ever set the length for numeric variables because SAS is able to fit any numeric variable into 8 bytes, regardless of the number of digits it contains. Let's submit this data step and view the data portion of the new SAS data set using the print procedure. You should immediately notice two things here. First, the length statement did what we wanted it to do. The variable ID is now 3 characters in length, and the variable BMI-cat is 13 characters in length. And we are able to see the entire value for each participant's BMI category. The second thing you should notice is that BMI-cat is now the second variable in your dataset instead of the last variable in your dataset. Here's a question. Why do you think BMI-cat is now the second variable in your data step? The answer is in your SAS program. Remember that SAS reads a data step from left to right, top to bottom. Also remember that the descriptor portion of the new SAS dataset is created at the end of the compilation phase. Finally, remember that SAS initializes the variable names and attributes in the program data vector the first time it encounters them in the data step. In our previous examples, SAS encountered your variables for the first time in the input statement. Now where does SAS encounter the variables for the first time? Now SAS encounters the variables for the first time in the length statement. So when SAS is initializing the PDV, it first creates the variables ID and BMI-cat as character variables with a modified length that you specified. Then it drops down to the input statement and continues creating variables in the PDV, ignoring ID and BMI-cat because they've already been created. Although it may not seem like it now, these details about what's going on behind the scenes are important. For example, if you had put the length statement after the input statement, ID and BMI-cat would both be 8 bytes. By the time SAS read the length statement, the variables ID and BMI-cat would have already been initialized in the PDV with default lengths of 8 bytes. Now you try using the length statement. I'm probably sent data in Excel files more than any other file format. Although the code we've learned so far cannot be used to import an Excel file, it's usually not a problem. Base SAS and SAS Enterprise Guide both have a really easy to use point-and-click import wizard for getting Excel spreadsheets into SAS, which you will learn soon. To my knowledge, SAS Studio does not yet have the import wizard, so if you want to use SAS Studio, you'll have to import Excel files in some other way. One option is simply to open Excel and save the file as a CSV file. Then you can read the data into SAS using the methods we've already discussed. However, another pretty versatile procedure that can be used to directly import Excel files is proc import. Let's walk through the import procedure and see how it works. You're going to start with the proc statement and the keyword import. Notice that the proc statement is typed over 3 lines, but it is all one statement because there's only one semicolon. Here, you're telling SAS that the output that should result from this procedure is a dataset called ht_wt5. The data file you want to import is located here. And this dbms equals xls specifies that the type of data you are importing is an Excel spreadsheet. The replace option tells SAS to replace this file if it already exists. Then, the sheet option tells SAS which sheet within the Excel workbook you want to import. GetNames equals yes tells SAS that the first line in the spreadsheet contains the variable names you want to use in your new SAS dataset. And finally, mixed equals yes tells SAS that the spreadsheet includes both numeric and character variables. Let's run it and view the data portion of ht_wt5. As you can see, the import procedure worked. However, you can also import the data using the SAS import wizard. To use the import wizard, you click the File drop-down menu and then Import Data. On the first screen of the import wizard, you will select the type of file you want to import. Here, we leave it on Microsoft Excel Workbook and then click Next. On the next screen, you will click the Browse button, point SAS to the Excel workbook you want to import, and then click OK. On the next screen, you will select the worksheet you want to import. Typically, you can just click Next here without having to make any changes. Then you're going to provide SAS with a name for the new SAS dataset you want to create, as well as tell SAS the library you want to create it in. In this case, you will name it ht_wt5 and create it in the work library, just as you did when you typed the import procedure. And finally, you will click Finish. As you can see, SAS's import wizard is a handy tool for helping you convert data stored in Microsoft Excel spreadsheets into SAS datasets. Now you try using the import wizard. Okay, so before you can ever analyze data or create any sort of report using SAS, you first have to access the data in SAS. You know how to build SAS datasets manually by entering the data directly into SAS. And you know how to read in data stored in some of the most common file types. This includes both character and numeric data. Let's go ahead and add one more little layer of complexity. What about files that include non-standard data like dates and currency? As you can see, this Excel spreadsheet contains the same height and weight data that we've been using, but 2 new variables have been added. The first is the participant's date of birth, and the second is the participant's annual household income. In this program, you replaced Excel with Excel 2 in the data file argument of the proc import statement. You should notice a couple of things here. First, the variable names. Spaces are allowed in Excel spreadsheets, but not in SAS variable names. By default, when there are spaces in the Excel variable names, SAS will replace them with underscores. But remember what I told you about shorthand variable names to save on typing. Trust me, you will probably get sick of typing date_of_birth and annual_household_income. You can either go back and change the names in the Excel file and import again, or you can rename them in a data step, which you will learn how to do later. The second thing I want you to notice are the values for the variables date of birth and annual household income. Remember that I told you that to SAS there are only two kinds of variables, character and numeric. This is still true. Now use the report generated by the contents procedure to view the descriptor portion of the dataset. This table shows attributes for all of the variables in your dataset. You can see that this is still a numeric variable, but that the format MMDDYY10 has been applied. SAS actually stores the date information as the number of days since January 1st, 1960. For example, January 2nd, 1960 has a value of +1. December 31st, 1959 has a value of -1. So the data value actually stored for participant 001 in the date of birth column is actually 7,810. But because the import procedure recognizes this as a date during the import process, SAS adds the format MMDDYY10. Finally, notice that SAS did not automatically apply a format to annual household income, so the $ and commas are not displayed in this report. You will learn more about formats in the next module. As you previously saw, some data files are stored in fixed columns. You may want to think of this file as a mini table. Each space can be occupied by a number, letter, or symbol, and has a row and column number just like a table or spreadsheet. For instance, the 0 in ID 001 occupies row 1, column 1. The T in Tom occupies row 1, column 5, and so on. The important thing to remember is that even empty spaces and symbols, like the / and the dates, have a row and column number. Once you know this, you can tell SAS where to go get the values for your dataset by specifically stating which columns have the data you want. This has some advantages over the delimiter method of reading in raw data. First, you don't have to worry about missing values. If you don't have a value, you can leave the appropriate columns blank. Next, when you write your input statement, you can choose which variables to read in and in what order. So, how do you tell SAS which columns the values you want are in? Here is an example of SAS code that uses a method called formatted input. The @ signs are called column pointers. They tell SAS which column the values for each variable start in. Following the variable names are SAS informats. These are pre-written instructions telling SAS how to treat the values of that variable. For example, you already know that the $ tells SAS to consider that variable to be a character variable. You may have already guessed that the number part of the informat tells SAS how many columns that variable occupies. Behind date of birth, you probably noticed the informat MMDDYY10. This tells SAS that the variable values that begin in column 26 of the raw data are date values that take on the form of 2-digit month, followed by a /, 2-digit day, followed by a /, and 4-digit year. Taken together, the 8 digits and 2 / occupy 10 columns. Finally, behind the variable income, there's a $7 informat. As you probably guessed, this tells SAS that the values you are reading in for the variable income represents currency in dollars and occupies 7 columns. Finally, all informats must end with either a period or a period followed by a number, usually representing decimal places. Let's submit this code and then take a look at the data. Everything is there, but notice the appearance of date of birth and income. Here's a question. What does 11,185 represent in observation 2? The 11,185 in observation 2 is the numeric value in days since January 1st, 1960 that represents the day August 16th, 1990. This is what an unformatted date looks like. You may be asking yourself, but didn't we tell SAS to format the dates and the income? No, an informat tells SAS what format the values are in the raw data. It does not tell SAS how to format the data in the new SAS dataset. Again, you will learn how to do that in the next module. What if someone is really nice and they send you the data already in a SAS dataset? How would you use it? Well, let's look at one final example. All you have to do is use the set statement in place of the infile statement and point SAS to the directory containing the SAS dataset. This includes pointing SAS towards a SAS library. This is a good time to point out another best practice. I already told you that I recommend that you never change your raw data. This is so that no matter how much you mess around with your data, you always have that raw data file to go back to. The same applies with SAS datasets. You may have noticed that in this lesson I kept creating new SAS datasets that were sequentially numbered, as opposed to writing over the same dataset over and over. I highly recommend you also adopt this practice. If you write over a SAS dataset, there is no way to get the previous version back. At best, you can start over with the raw data and retrace your steps. You now have a basic understanding of how SAS processes a data step. You also know everything you need to know to get data into SAS from several common sources. If you have any questions about any of these videos, please post them in the appropriate discussion board.